Hello, this is Kuda an Open Lab seminar, the first session in fall 2025. We start a little late compared to previous semesters. That's due to general travel commitments of people who were organizing. Today, it's our greatest pleasure to have Meeyoung Cha, who is very well known in the field of cultural data analytics since a very long time. But what you may not know is Mia is scientific director of the Max Planck Institute for Security and Privacy since a year, right?
Yes.
But she's also still professor at KAIST, the Korea Advanced Institute of Science and Technology. For those who don't know KAIST, that's the MIT of Korea. And that is not just a euphemism. And Mia will speak today about AI, society, and computing, leveraging global data while tackling ethical challenges. This will be about an hour talk, and then we're gonna have a discussion. Thank you very much.
All right, so thank you so much for inviting me. I am really thrilled to be here. I had the invitation for several years, and I've been meaning to come by, and now it's really a close hop away from Bochum, so I'm really happy to be here. So today I want to talk about what I'm really passionate about. I have computer science background, but I have worked as a data scientist, and I have been working primarily with many of the NGOs and IGOs. So I want to share that experience with you and also talk about what are the new challenges with AI, how is AI, generative AI in particular, is changing the way that we are perceiving information, we are understanding about the world. And if there's a little bit of room, I also want to share some messages to the younger researchers who's aspiring to be great, to be on the long trajectory of research. So there's some mentoring and a few slides on that as well. So I'll get started. So I want to take you to become data scientists with me today. So think about your favorite city in the world. Tallinn is really beautiful. And think about all the data that you could get from the city. If you were to do research about what people are talking about long time before, how would you go about that? You know, people have called random phone numbers or go to the street and ask people. But nowadays, we have social media, we have blogs, we have emails, we have everything that could be searchable, digitally logged automatically. And some information are really real time. It's not there like fire alarm. It's happening right now. So you really have to carefully listen to live streaming of the event and air quality. And obviously some information is not true. There's either intentionally or mistakenly false. So there's misinformation, but that's fine. And people talk about their opinions, view, whatever. So it's not the lack of data, but it's more of a lack of the ideas that what do we want to make use of all the rich amount of data. So this is a picture that I have in mind wherever I go. What is substance of information formation, propagation, and if you were to see a city, would you be able to guess what kind of information that you would be exposed to? What kind of information that you would be exposed to over a lifetime, and how does that shape the decision-making of a person over tens of years? And how are people connected, and how does that come into play? So all these interconnection and the geography and the living environment, I think it's really, really important for us to understand. So how do we harness the rich activities in data? And you could do so many things, and you could use the data for so many different purposes. But the NGOs that I collaborate with primarily use it to drive social good. So here is one example of World Health Organization targeting information sources like disease outbreak signals. And it's really amazing. There's a team in Berlin and a few other places that's monitoring social media and internet usages. And it's just looking at what people are talking about at different regions of the world. And just in Africa, can you imagine how many local outbreaks WHO is able to track on a given week? There are about 2 to 3 outbreaks every single week. And these outbreaks are really local outbreaks because you could combine them later with the hospital visits and then you could see it was an outbreak or not. People search for different terms, people come to the hospitals and so on. And if you translate that to the global scale, it means there's outbreaks happening continuously. And it's just a matter of time with increasing traffic and climate change. We will be seeing lots of outbreaks happening throughout the world. So this is just one example of one organization looking at this. And what would you need to do that? You need to have access for large amount of data. You need to have the computing power to pull all the heterogeneous data sources together. You also need to have data scientists who could imagine the ways for combining different sources of data and detecting the new patterns, novel patterns. So there's a lot of things that that needs to happen to detect any outbreak of any novel information, and so it takes the human resources and it takes the computing resources, and increasingly AI needs lots of GPU, so a lot of funding and so on. And it's very challenging for NGOs to do that. So what I try to do as a professor in a university, it was my mission to use part of my research time as philanthropic work, and then I work with NGOs, although I bring my own funding to these studies, and this has been going on, and I am really enjoying what we are doing in our lab. So I'm going to give you just a few examples of the research that we have been doing. So in one of the research, we collaborated with UN Data Pulse, and they have a few locations in the world, but the one we collaborated is from Jakarta in Indonesia. So my PhD student went to Jakarta as an internship, paid by me. I fund the study for my intern, for the student. And there we worked together to look at fluctuations in food prices. And Indonesia is a very, very interesting and challenging environment to do that. There are more than 10,000 islands and then over 8,000 islands people reside. And there are so many tens of different languages used. So how do you go about getting the average prices of important commodities like chicken, chili, whatever, the beef, onions? It would take a lot of time for the market researchers to go to the local market, collect the food prices, and then come back and report to the central statistics division. And then it takes about a whole full week to do that. But also what's interesting is in this country, everyone loves to use mobile phones, and they love to talk about what's happening in real time. So people talk about, oh, the prices are really high today, it's expensive, there's something happening. And what needs to happen is there's a lot of noise in the data. So we need to know, how do we get the true data out of all the noisy data? And people don't necessarily say the food price went up by this much unit. So we also need to infer.
Oops.
Oh, I'm cut off.
When we share?
Yeah, okay. So let me just reshare. But this is Eduroam cutting me off, so I will start resharing. Okay, but you can guess at the end, we would have an algorithm that would continuously monitor what people are saying on social media from different places. And then we would project the beef prices going up or down. And then after about a week later, the actual market price will be collected at the central statistics division. And then we could refine the algorithm again. So something like this. It took a tremendous amount of effort, but at the end, it was a code shipping, and there's a website that people can get access to, and this will help people make more informed decision about whether you want to stock up on some commodities or how do you invest. So things like this are really, really interesting to me. And in another collaboration, we work with the World Customs Organization. And here the task is you have so many imported and exported goods between countries. And when you export something, it's good for the country. So there's usually no tax imposed. But when you import something, the tax is imposed on the imported good. And as an importer, it is naturally you want to look for how do you describe your item so that you are probably, hopefully paying not extra tax, but sometimes there's also fraudulent description. So depending on the item, if it's dried beans versus the raw bean, the tax rate might be different. If it's a luxury watch versus a very sporty functional watch, the tax rate is really, really different. So we look for signals where these descriptions of the items are somehow standing out, because in many developing countries, the customs officers rely on human insight to read these descriptions, and then they open up the packages, because you cannot basically open up every single package. You have to use some insight. But with increasing amount of imports, it was becoming impossible to just rely on the human insight. So we developed, together with the Nigerian customs and a few other customs offices, we developed an AI algorithm that would tell the officers which items you could open first, so that you maximize the rate at which you catch these fraudulent things, and also you maximize the tax imposed. I think I'm kicked out again, or it's okay, it's okay.
When I use, there's another one which is
Yes.
Called TLU. It's open.
Okay, TLU, okay.
That should work.
Apologies. Okay, I'm switching to TLU.
Can you back in?
Yes, I'm back in. Okay. Okay, great. So at the end, we had a really, really nice algorithm that was functioning really, really well. But we found out that the customs officers didn't want to use our algorithm, because for them it was a black box algorithm, and they used to rely on their human insight for the decision to make the decision to see which items to open. But if a black box algorithm just tells you open things, items this, another item that, and it's taking away human agency. So after interviewing why there's a resistance, we got to know that if we give reasoning for why this item is likely fraudulent, then the officers will more likely to use it. So but there's a cost. To make the algorithm explainable, there's a little bit of a performance drop, but once we proposed the reasoning together with the results, the customs officers were much more happy to use it. But then there's still resistance. And then COVID happened, and then it was the time when it was also for the customs officers, it was really hard to work. And things like, a crisis like COVID really pushes the industry to force the industry to adopt AI at that point. So we also make this, because we collaborated with the World Customs Organization, we make the algorithm for free for all the member countries. And for me, it's an algorithm, but for many of the countries, it's like, if you have 0.5% increase in performance, that means huge amount of revenue, because revenue could be up to 20%, 30% of the whole, national revenue. So it's a huge thing, and we are really excited that it gets used. And at the end, we also get to do some research out of it. So, but And then in my other part, I have long been looking at misinformation propagation. This is a colleague of mine from KAIST. And let's say we have, I want to give you one example of what I mean by misinformation detection. So we have a network. So on social network, we hear someone saying interesting things, and whoever is following would propagate further and further. And if you were to maybe change the person to a completely different influencer, then you would immediately imagine, oh, this information would go through a different set of people because it's a different influencer, different topic. And then could you imagine for every single information, would you be able to imagine what kind of propagation network if a seminar announcement, Kudan seminar announcement would propagate through versus if this is a conversation about, I don't know, marijuana or Trump, or, you could imagine it would go through a specific set of people who are usually interested in that topic. So maybe the hypothesis here is that information leaves a trace, just like individual humans can be identified with fingerprints. So maybe each piece of information has a unique trace. So that was the assumption that I had long before. And this is just one example of how we can make use of detection based on this pattern. So I'm showing you here two propagation patterns. We have complex network researchers here. So each propagation means people talked about them. So both information propagated very, very well. On the left-hand side, what do we see? There's no large, giant connected component. It's more like fragmented network. On the right-hand side, things are connected very well. Both propagated very well, but it shows very different pattern. And can you imagine which one is a rumor and which one is a true news? Can you?
True.
Yeah, rumor or versus facts. One of them was a rumor, one of them was a fact.
But what exactly is written on is shown on this graph?
Oh,
Points
yes.
are people.
Exactly. Points are Twitter users, and there's a link if someone replies to you or retweets or they're following and then they propagate in the community.
Yeah, but then it seems to me that on the right-hand side it is much more propagated. You said that they're equally propagated.
No, not equally, but they're still on the left-hand side. The participating nodes are huge still. So it's a very well established.
I think real networks have a giant connected component, and therefore the right one is real and the left one is artificial.
Mm-hmm. Any other thought?
Other way around,
Yeah.
I think.
The right is fake.
The right one seems fake. Yeah. So this is just one example, but in this particular example, it was the left one was the rumor and the right one was fact. And the reason it gets connected easily is because when factual information is spread by high degree users, mostly to the low degree users, so they have millions of followers and easily connecting. But misinformation, rumors usually propagate through low degree users generally, and then the information also, the average degree kind of increases over time. So it gets connected much later. And another thing is, this is an open network. This is public Twitter network. So if you hear something interesting, if you retweet, that can harm your reputation. So people may silently consume. We may see a completely different pattern if we were to see closed networks. So in this case, it was on average, it was, rumors were fragmented, single tone, smaller tones, and then facts were really well connected. Once you have this understanding, you could use machine learning, deep learning, other things for detection. So after maybe 50 messages or 100 messages, you could say, okay, this is propagating similar to other rumors versus other facts. But that doesn't mean it is a rumor or a fact. It just can give you to the fact checkers more information about the way that it is spreading. And then when COVID started, as a misinformation researcher, we were just hypothesizing a lot of different cases of rumor propagation. And then COVID was a moment for me to really observe the real propagations of rumor, happening. And I was in Korea at the time. And when COVID started, Korea, China, Taiwan, few Asian countries were in lockdown. The rest of the world was not in lockdown. And I closely monitored the fake news in Korea. And then I asked my Chinese colleagues, researchers, and they would say, oh, that was last week's rumor and you receive it now? And it was funny because COVID rumors will not come to my city until the virus actually, so it was more like we had to wait until we have enough people who are infected and then the rumor makes sense. And then I saw the same rumors, which has been already debunked in Korea, Taiwan, China, and then they reappear in Italian, Spanish, and other languages.
And do they come back in Korea? So are there circles of the same rumors at some time?
Not the same rumors, because once people see a fact check and then you see the rumor again, it's no longer interesting. Yeah. Maybe if there's a variant rumor, and it could be. So we wanted to see, okay, can we quickly collect all the popular rumors that really influence people in Asia, and then we translate them into different languages and we propagate them to the rest of the world. So that was how things started. And here are some examples that were really popular across the world. So drinking alcohol, you pretty much saw all of that, right? Hot air dryers can kill the virus, and smoking will kill the virus, and everything. There were rumors that were really locally propagating, like I hear Chinese people really like fireworks. So there was a rumor about fireworks will kill the virus in the air, and eating 9 eggs a day. It has to be 9, exactly 9. Maybe there's a number 9 as a good sign. And this rumor was also very, very popular. Yeah, so there were rumors about, this the Korean medicine will be good for curing the virus in Korea, but that didn't happen in other parts of the world. So we look for global rumors with global appeal, and we wanted to create a short infographic. So what we did was, we collected about 200 rumors from social media in China and Korea. We worked together with health officers to make sure that these are fact checks. We know the fact checks. And then we designed the background. We put all these rumors and fact checks online. People participated in translating them into different languages on Twitter. And we had, volunteers who just gave their free time translating. So and then once we had the design, we would put different languages, and this is a rumor, this is a fact, and then we propagated them. And the reason we wanted to use local languages was because if it's just in English, then many local people will probably not read it, and that's the people that we want to reach. And at the end of the propagation, together with the propagation, we left a survey so that people who wanted to get back to us can get back to us through the survey. And that was the people we reached. We got 50,000 survey respondents, which means that our campaign was far more reaching, but then we still got really large number of survey respondents. I think it was because people were really hungry for information at the time, and many NGOs were not producing any fact check because they were more careful about sending any messages at all, and we were more proactive at the time. So it was a huge success. we wrote, we participated in some books, and then we got invited to World Health Organization to give a talk on this project, and our team won some awards in Korea. So it started as a hobby project during COVID, but then it was something that really, changed my, yeah.
Do you understand correctly that for an analog, so is this, a sense that you kind of derived an inoculation against like the more prevalent rumors and spread them before the virus of the fake news could get there, and it worked?
Exactly. So you're exactly right. So it's kind of like a vaccine, because once you see the rumor and once you see the fact checked first, and then later the rumor arrives, it's no longer interesting, right?
But have you checked that it works? That in the places where they took it, then the rumor spreads less efficiently.
Yeah. Yes. So we have a +1 paper that tests the believability of the rumor and then their future intent to take the vaccine, because the vaccine was not available at the time, and lots of rumors were targeting vaccines, like don't get the vaccine. So the question we asked was, have you seen this rumor? Do you believe this rumor? Here is a fact check. Will you be taking vaccine if there is vaccine in the future? So we had series of questions, and people who already start to believe in some rumors, they will, even after seeing the fact check, it was not enough to convert people's thinking. Yeah.
Maybe for later discussion, but just so it doesn't run out of my head, I wonder, have you had any discussions on or checks about how much this is then dependent on just sort of this seemingly tendency for people to run was the first thing they hear.
Yeah.
And then of course then the bias against to be like, because if people are already primed that, oh, they will try to like spread you doubt, then it will be, so that will be the first information that hit them and counter them.
Exactly.
I can see that in a normal circumstance, this is really cool, but I wonder how this could be hijacked.
Yeah, yes. That's a really good point. And this was perhaps like the first pandemic that we all experienced, but let's say we have COVID #2, another one. And if we are starting, if we are bombarded with both misinformation and fact checks, will people behave the same way? It's not very clear. And if we also give too many fact checks every single day, then no one will read it as well. So we don't know. At this pandemic, it was very effective. A pre-exposing fact check was very effective, but it is really unclear if we can replicate it and how we can do that, because people will get bored just by looking so many fact checks at some point. And because we had so many respondents and so many countries, we could actually analyze. And here is just one finding. On the x-axis, I am showing you countries that are from less developed to more wealthy, higher GDP per capita. And then on the y-axis, have you seen this rumor? And countries with lower GDP per capita are far more likely to have seen the rumor. So that means they don't have the infrastructure, and they really have to take extra effort to also fight the infodemic. So we could observe a lot of things like this. This is just one testimonial, like example emails that we received from this project. So it was also, as a typical researcher, we're usually behind our screen and just working by ourselves, and was a chance for us to communicate with people. It was really rewarding. So as a research community, what have we learned so far about rumors? I always want to bring this paper. It's by a Facebook data science team. It's not my paper, but this is a beautiful visualization showing rumor propagation. So blue ones are Facebook users, and when it's shared, it's propagating. And when someone writes, "This has been fact-checked," it appears as a red node. When there is a red node, usually, many times the propagation stops. But just because there are so many branches, you would imagine, even if in one conversation, people say, "Oh, this has been fact checked, it's a rumor." there are so many branches and it's so tiring to continuously find them. And, so it really shows how important this repeated flagging is. And I think it really shows, this paper shows the challenges with fake news. Another interesting paper that is not by my group, but they did a really interesting study of looking at when is a good timing to show fact checks. So you show the fact checks and the rumor together, or you show the fact check first and then the rumor, or you first show just the rumor and then later the fact check. And then after 1 week or 2 weeks, you ask people, do you still remember what the rumor was about? So how memorable they are. And obviously, when you are fooled and then you are given the fact check, people tend to remember it much better. But the drawback of this mechanism is many people are not interested in following up with the fact checks. They are might be just fooled. And there are other studies that say people who follow correction messages or fact checks on social media tend to be high degree users, people with many followers. And then also there's a neuroscience study that's a little bit proposing why some people are interested in the correction news versus the majority are not. So there's the part of the brain that makes them feel really happy to give correction and propagate the true news to people, and it's a very small set of people. So it's very interesting, but in real life, how do we make use of findings like this is another open challenge. And then when the large language models came about, there have been studies, but by the same group, about looking at using large language models to debunk fake news. So you bring in people who have strong beliefs about rumors to the lab, and you let them chat with the fact-trained ChatGPT for on average 8 minutes, and then they're able to somehow flip their thinking and become more open about receiving new information and so on. So there's some really interesting positive impact. This is a science paper which is really, really awesome. And it's nice because LLMs, chatbots can work 24/7 and they can continue on the conversation without being, too tired, and it could work for hours and hours. So if we are able to use large language models for debunking fake news, that could be great. But that also means, can large language models be used to spread? Obviously, if it's able to debunk, how powerful could it be to spread as well? So there's both sides. So there's many papers about looking at the factual challenges in the era of generative AI. And more recently, one of the research that's really makes me think is what happens when we start delegating a lot of the human decisions to AI, such as, oh, go chat with this person and make a deal or do something. So this is a paper by Max Planck Institute in Berlin, and here they do a very simple game. So you flip either a coin or a dice, and then depending on head or tail or the number, you will get paid. So if you say you got 1, you get $10. If you get 6, you get $60, for example. And only you know this. The survey researcher doesn't know this. What would be the average people report? More than 3. Also, on average, maybe 4 to 5. So people will cheat, maybe like 1 or 2 scores more when it's.
But average is 3.5.
Yeah. Which yes. Yeah. Average is 3.5, but people will cheat slightly a little bit. Understandable. But when people were reporting to an AI and then they received the money, they reported 6. So somehow the human, their dishonest behavior seems to increase a lot when we start interacting with AI. And the companies can do the same. When there are companies that are using AI and they can always delegate their faulty things, that, oh, this was because of AI. And people also are more understanding and yeah.
It's got a probably just anything that has a little bit of like sort of assume and building confusion in it. You tend to be like, oh, I can tweak it a little bit because it'll be so. It's because of the messy, confusing thing in between.
Yeah, exactly. And this is the term they saw, so companies can make AI as a liability shield and just hide behind, and just say, oh, this is AI. And also not just the companies, but individuals seem to increase in their dishonest behavior. So we really need to see how, if AI is being used to deliver critical information about the fact checks of outbreaks and other things, and what will happen, we will really have to see. Maybe given the interest of time, I will just skip this. Okay. So far I talked about what kind of information propagates online and how people, information consumption patterns. And now I want to take you to a completely different space of geographic information, maybe observation. I wanted to know what kind of living environment we live in, because I believe that's one of the critical factors deciding what kind of information you receive. Because you are now in Tallinn, you will be able to access certain type of information that other people cannot. So because you are in this room, you are accessing certain kind of information. So our environment, our human network has a lot of things. I think it decides a lot of the information space. And that has been completely overlooked in my view. So we wanted to look at what kind of data that we could gather mostly for free. It's really hard to get platform data, but we are able to get satellite data for free for many of the regions. So in major locations, particularly in Europe, every single location you pick, there's a satellite passing by every 20 minutes on average. So we could get 1 meter per pixel images every 20 minutes. So which is, a lot, right? But if it's not a major place, if it's like an open field or the ocean, we won't get that. But in major places, we have really high definition images, and it could go up to 30 centimeters per pixel or 20 centimeters per pixel, but then it's no longer free. But 1 meter per pixel, in many cases, it is already free. So it's abundant data out there. And besides, there's some drone data is becoming available, surface temperature, all these other data sets are becoming available. So once we have all these signals, what can we know about the human living environment so that we can later combine that to information propagation? So classical studies looked at nighttime resolution, nighttime light intensity. So this was a really famous picture taken by NASA. It's showing North Korea, and you only see Pyongyang as some light, and then the more light you have, the bigger the city it is, and there's a strong correlation that the economists have confirmed. But here it's mostly blackout. But this doesn't mean that there is no economic activity happening here. It's just that there's low electricity supply, so that there's just no light at nighttime. So this nighttime data is really amazing, but to look at developing countries, it's not a good fit, as you could see in this picture. And nowadays, because the daytime satellite images are becoming freely available, we are able to utilize them for every single places. It's just that, as I said before, major locations, we have more frequency of data updates. If it's smaller places, as we don't get as much frequent updates. So here is one example of North Korea taken from 2011 and 2018. So you see, this is a river separating North Korea to China on this left-hand side is China. It's a train station, and 2011 to 2018. As a human data scientist, what would you say? What happened between these years?
Something was built over there.
The infrastructure got bigger, which means there's a train station. There's more trade happening between China and North Korea, and the warehouses have to be bigger and so on. So it's a
So these are warehouses,
yes.
not, for example, army barracks or something.
Wait, from the top, we can only see from the top.
Yeah.
Yes.
Can we identify what?
Exactly. So
Chinese, which is red roofs and blue roofs in between.
yeah, it could be. That's interesting because you see the blue. Yes. So it's a human. We have the human insight by comparing these images. But how do we teach a machine to do that? And can we teach a machine to do that? And that was the question that we started looking at. And we had the old nightlight images, and then now with the much higher resolution daytime images, we started producing a map of economic development for every square kilometer and this can be done in any parts of the world. But we still need to get a very clear date. When there's clouds, we cannot see them. So we want to average across some days. And so we cannot go to North Korea, but we are able to see satellite images and we can track new buildings, and then we can track potential economic development that's happening every single year, every single season. So we are able to do that.
So what is the color on this map?
Yeah. So this is this is the raw daytime images, and this is the night light. So outside is pretty low, and this is our computation results showing for every kilometer by kilometer square. Red means much higher economic development and lower economic, and this would change over the years. And we can apply the same thing, same algorithm to different countries in Asia and other places. So when we did that, we made the algorithm and then we make it like a human AI collaboration because there's no ground truth. So we ask people to label just some sample of images and say, which one looks more like urban versus rural? So we made a little game and gave it to people. So we had experts, and some experts were from economies, some experts were GIS experts, some experts were North Korean defectors who fled North Korea. And we saw very subtle changes and differences between what the defectors claimed as wealthy regions versus what the South Korean economists and GIS experts said. Can you imagine what would be the signal of wealth in North Korea from the sky? Like, for example, if you have a swimming pool, like, and so on. So the North Korean defector said, if you see solar panels, that's a signal of wealth. And it was really surprising to us because that's not a wealth in South Korea. It's more like maybe you're environmentally or you want to save energy and other things. But if you have more electronic equipment, you need to have solar panels. So you need to have like multiple ones and larger ones. So the region with many solar panels were considered rich. So this really, again, showed AI cannot be on its own. We really need the local people's input, and there's nothing that would replace that. Yeah. So here's another blown up images. You could really see the raw satellite images, and it's our computation estimate, and this is the nighttime images. So the new data sources are giving light to the previously unapproachable regions, and it's really exciting for me. So our team is working on projects like this, and there are a few other teams in the world who are also looking at similar things. So this is Colombia team together with Facebook. They use Facebook user counts to estimate wealth in different cities. And they also do like 1 kilometer by 1 kilometer, but they're focusing on more developed countries than the least.
How much do you use this related to? I know that Facebook has this whole host of data sets.
Yeah.
The most interesting one I like was the mobility sort of score.
Yeah.
First, where like based on your like where your phone moves around with GPS location.
Like a foreign car or something.
Yeah, and I had data quite coarse-grained about how mobile people are on average, how many meters from this place. How well does that correspond over different cultures for prosperity or so on?
I cannot answer that question, but there are studies that look at Facebook login history to show longer term migration. So people moving from one country to another, for example, Ingmar Weber's group and Emilio from MPI in Rostock. Not Ferreira, but there's yes. Yes, so they look at the human migration from Facebook logs and so on. So you used to log in from this continent, and then now you continuously log in from another continent. And can we represent like how many people are moving continents based on Facebook? But not to that detail of like what is the how wide is your daily radius? Kind of like I cannot. Say much. There are studies that look at the like a levy like patterns of human flight distances, but
do you have any estimate? China is missing there because they don't have Facebook.
Yes,
but
exactly.
One of the interesting things is that maybe there is different penetration from different social networks in different countries. So do you see this sort of like systematic shift? Like, for example, is the Philippines, you see the sort of like, you could say the right topography. So obviously Manila is sticking out the most, but if only 30% use Facebook, while in Indonesia, 80% use Facebook, do you see this country level sort of differences? Or?
Yeah, I would assume so. Okay. So, and then to do this, they collaborated with Facebook so that they also, Columbia University also has the access to the data set as well.
Just to clarify, what is the height and what is the color?
Oh yes, so the height would be the index of potential wealth, so economic development, and you could do the same for population density and other metrics as well, right? So in this case, they call this like the wealth map. So it's somehow representing.
Is it per capita wealth or is it overall wealth?
They also look at what kind of buildings are there from the satellite images together with the Facebook users. So it's a combination of some human infrastructure and the number of Facebook users in the region.
And the color?
The color, I guess that I don't know. It's a good question because the taller ones are not necessarily darker, right? Yeah. Oh, here on the right-hand side,
Cambodia is a high one that is.
So relative, the brown one, the browner it is, it says the relative wealth index is high, and the purple one is the relative wealth index in this paper is low.
So this is like a two-dimensional color.
Yes, two-dimensional color. Yeah. So there are teams like this, and I think it's a really interesting space maybe it takes about a year to get used to the satellite data, but once you start using it, it's not that difficult. So I think there's just so many things that we could start monitoring using this rich data. So
is that something which you could recommend, like for? I had to laugh when you said like you can get a 1 meter per pixel image every 20 minutes because I spent several weeks in my PhD to get a sort of like picture of Rome. It was, I remember it was 2,500 euros, and I tried to convince the director of the Max Planck Institute to actually spend that money, and eventually I got a no, and then 2 weeks later Google Earth came out. Problem solved, right? But still, this was sort of like a kind of surreal thing that you had to wait, and then like, you know, we spent lots of time mounting old aerial images and satellite pictures, and now if you say, oh, you can have like, you can basically watch it.
Yes, you watch it every, yeah.
But for free, who gives away this data for free?
Sentinel is the one of the longest running satellite program, and this is a like lower level, 10 meter per pixel.
Okay.
But this has been free for like, I would say like more than 15, 20 years.
Okay.
So you can really go back in time, and that's amazing because you could see how things have changed. And now, if you go to the Google Earth engine or other places, there's Esri data set. The 1 meter per pixel is in many times free, but they don't sell it for all of the regions. It's sampled images, and we also partner with some places, so we get 50 meter per pixel images, because then you could see whether the buildings are ruined because of the natural disaster. So in some cases, you need more higher resolution, but not all the time. So it is free. And I think it's going to be even higher resolution ones will be free in maybe 5-10 years, because every company says we're going to be launching out hundreds of satellites in the next 5 years, and the data is becoming really cheap.
Yes, one of the interesting things is the going back in time issue, right? Where you have, particularly in cities that are around for a while, where you can see that this global warming, for example, more people add air conditionings, and then once the air conditionings are there, the city becomes even hotter. So there's these like weird effects, which you can only see if you have pictures from the 70s, 80s, and 90s.
Right,
Otherwise, you never see this, right?
Right. And also some of the images, you can see different tones of colors. So you could start to see which regions are putting like white color on their roofs because of the air, you know, the heat. Yeah. So there's a lot of, or also what is a predominant color of a given city? You can do so many cultural studies. I think the data is there. So you could go back in time, and you could, so in one project, we also looked at the trees, because trees, when in satellites, there's RGB, but there are lots of other channels, and one of them is a reflection of the light, and that light, that number will tell us, is this a tall tree or a short tree, a grass, or what kind of crop? So we can infer so many things. Is this a water body? And so we looked at what proportion of green space individuals have access to in different cities, and we wanted to correlate that with many things, and one of them was a happiness index. So for countries on the top 30 by GDP per capita, there's a really good correlation with access to green space per citizen and happiness score. So green space doesn't mean they are becoming happy, but if the city has put the effort to make green, what else it would have done? So I think it's a good measure to say. But the top 60, you don't see the correlation anymore. So maybe at first it's the economic boost, and then at some point it has to be the well-being, you know, different things. So we can do studies like this, and every research, we work with NGOs, so we release our code, we release our data, and UNICEF has used our indexes, our green space index, to correlate with the children's happiness. And we were very happy UNICEF used our data for their primary report. And here you could see Korea has the lowest happiness and the lowest among the studied countries. So it was not very well advertised at the time. But there's so many things that you could do, and so many indexes you could compute from satellite images. So it's just like, come bring your idea and just apply it to the data. The data is there, and it's just whatever you want to think of.
And what is the country at the very bottom? T something.
PR,
Turkey.
Turkey, yeah. Turkey has also, seems like has really low happiness and
Yeah, but
yeah, Finland, do you see, what's the code for Estonia?
EE. It's also-
EE.
Yeah.
yeah, it's
Where is
it's-
EE?
Uh,
You're very good. Okay, Finnish and green.
Interesting because this here the greenery is for like 3 months only. Satellite
Yes, you're very correct because we only look at the summer and then we also look at the this December for the southern hemisphere. So we
I think it's very important if you look up there, like Finland, Latvia, Iceland, Estonia.
Is it Iceland
They're all,
or is it Israel?
is it Israel?
yes,
That would be ER,
yeah.
right? The thing is, all these places are low population density places where you can probably take a walk. Like, you don't really need to invest to build a park. You can just walk for 20 minutes to be there.
Exactly.
Yeah, well, if it is Israel, then it is not the case there.
Maybe could be Iceland or
It's Iceland because
Yes.
Israel would be IR, right?
So it's not the raw amount of green spaces, it's divided by the number of citizens in the cities. So it's accessibility. And it's not if you have green space far off, it's like within some radius of a city, you need to be able to walk and be accessible. So it's
Yeah,
So if you have some urbanism background, right, there's very clearly you can see in the cluster, like there's Hungary, Germany, Czech Republic, this area, Italy, there's places which actually have, despite the density, investment in parks. So there's a lot of parks. The US, for example, would be less expressed there because it actually has green spaces, but
you need a car.
they're typically not accessible.
Yeah,
There's a fence
exactly.
around it, right?
Yeah.
So that's quite interesting.
Yeah,
actually.
yeah. So we make the code and everything available together with the paper. So it's come with ideas. And I think this could be a really, really nice space for maybe students who are starting their research. And now that was like the first year, like year 1 to 3. And now we have been looking at this for about 6 years. And what we are looking at is we want to look for patterns of extreme poverty and maybe human right deprivation. So one is the patterns of slum settlements. And this is Mongolia. In these white tents are called gers. They are supposed to be used in the open field because it's a nomadic people. But somehow they started appearing in the city center, and then they lost their mobility, and it's becoming as a place for people to live. There's no electricity, and because there's no electricity, when you cook, you have to make fire, and the children living inside this gers will have to smell the smoke, and this impact will come back in 20 years, 30 years in time. And because it's a very particular shape, we can exactly count how many gers are happening in which side of the capital, Ulaanbaatar. And we also know the slope of that region. So is it in a hard to walk area? How far is it to the nearby hospital? So we can do all of these calculations. So this is one of the projects that we are really interested in. This is just published in the NPJ Urban Sustainability. We have series of work coming out. And here's one example, NASA images of the Pakistani flood. And just within the 24 days, you see it's so visible what happens. And if you were to apply machine learning over higher resolution satellite images, then we can see how is the recovery happening, how many buildings have disappeared, are there new facilities happening, so we can track so many things. Okay, so I talked about the information and I talked about the geographic information, and I just want to try to combine them. And I call this information geography, and this is what I want to, what I'm really passionate about these days. So how do we combine these two? And I will, maybe not the best example, but there are some theories, there are some flawed, there are some doubts about the theory as well, but there are some theories that try to say, okay, when you have environment with broken windows, the crime rates are high and so on, but it could be used as a weapon as well, right? So there are some theories connecting the surroundings and people's behavior. So surroundings shaping people's behavior. And I get to see images like this every day with my researchers. So this is a picture of Mumbai in India. So you see these are skyscrapers, really fancy buildings with parks, and then just one street. And on the other side is a slum. So remember, I started with the image of a city and these bubbles of what people are talking about. Now think about some discussion on air quality. If you don't know where this information coming from, even if it's the same city, the information will be vastly different. So I keep thinking about, we really need to know where the information is coming from, what is the surrounding and how it's shaped. So this is just one image. Another image is, this is Johannesburg, South Africa. Super fancy with swimming pools and fancy housing, trees, and one street. Again, it's a slum area. So we are doing slum detection. We also want to work with people to see what kind of information, social media posts are happening from both sides of the same city. So to combine the geographic information together with information consumption. And then if you think about it, now increasingly we're spending a lot of time online. So it's not just our physical environment, but also our virtual environment that could potentially shape our thinking and how we perceived. So this was a really fun article on Business Insider. This person is this lady on the virtual world. So who are you on the virtual world? If you are spending on average an hour on the virtual world, and if your virtual world looks like this versus something else, and will that also shape the way that we perceive things? So I'm interested in expanding this connection with space and information to the virtual one. And there's another dimension, which is time space as well. So if you are able to connect to a future time, so there's the virtual space and also the time space. And I met someone who does criminology research, and then maybe I just show the research, and maybe that's more fun for you. So he works with people with the juvenile, prison. In prison, they have scars in their face. They're part of the gang members, and they don't see the future. And then they show avatar reflection of their present self, and then the ones with the future self that looks a little bit older, but with less scars. And then you put them in a nicer environment. And then I hear the behavior, the offline behavior starts to change. Because if you are able to connect to the future self, and the future self is okay, it's still alive and it's no longer a gang member and so on, and then things start to change. So this is one example from this Max Planck Institute on Crime Research. So this is showing someone from the prison with the counselor, and this is there's like a time machine, and then you do the time machine, and then you could see like an older self, and then also the counselor becomes old. And so they put people to this virtual environment, and then they make people meet their future self who is still alive, and then see how their behavior changes in the offline. So studies like this are really, really fascinating. I think this is really trying to combine how information and our perception is all connected. Who are we connected to on social network and virtual space, and maybe perhaps even the future space could really also reflect what kind of information that we get to consume today, and that also reinforces what kind of decisions that we can make for tomorrow. So this information geography concept is really something that I would like to pursue in the future. And altogether, my lab is called Data Science for Humanity, and we are passionate about looking at like all these space geography information, but at the same time, we continuously work with NGOs and we try to solve problems that they are interested in, and we bring the AI tools and the computational tools to solve it. So hopefully more people are inspired to take on this journey together. And I will stop my talk here. Thank you.
Thank you very much. I need to say there was clapping in the room because Zoom zones out the clapping. Yes, so thank you, Yuri. Let me zoom out a little bit so we can actually see the people in the room. Other direction. Yeah, thank you very much, Meeyoung. If you unshare your screen, I think then we can actually, yeah. Okay, so yeah. Super interesting, and I think this is actually sort of the most clear kind of like data science contribution we had in the last 5 years, which is its own discipline in a sense, right? Which is often or most often done in other disciplines as a sort of way to do the discipline, like data science to do art history, data science to do criminology, whatever. But the interesting thing is if you're sort of like, if that is your center, you can do all these other things. And then I just came back from a conference symposium in Czech Republic, where most of the people came out of archaeology and art history, where 85% of all computer applications is actually this geo stuff. So geographic information systems, the map is actually sort of like the major point of reference of like where stuff happens. And it's quite interesting that you go the other way around, like you come from behavior and from data analysis, and now you say, oh, there is actually geographic maps. That's really cool. Do you see that this is something that you bring something to the table which people in geographic information science never do because they're just like too much in their sort of thing?
I think it's just the beginning. So maybe in 5 years' time, the geographers will be much better in using AI, and they will start proposing really fun things. But now the hurdle to use computer vision is pretty high for now. So I think maybe that's why someone like, having computer science background in my group, there's a lot of computer scientists. So we work together with geographers, economists, and then we work on these projects. But I think this hurdle is becoming lower and lower. We can now start coding without having to actually, type anything. We can do prompt coding. So I think in a few years' time, I would assume geographers or art history or anyone will be able to use it so freely, so easily. So,
the question is like, how do you make them adopt the freedom?
Adopt the freedom.
That's, I think, the key issue, right? Like one of the core problems that you may have encountered in this area is to say, why do you have all these new questions? You don't solve our old questions, which is typically very defined set, right? But you clearly do that. You clearly are foraging for new questions all the time, which is sort of cool.
Yes, thank you. So maybe one thing that I learned from working in my Facebook as in industry was that there were people. The data science team we had amazing people, but also I thought that what they were really good at was connecting two different data sets. And just by combining that, you could start asking questions that people could not ask before. And that was so interesting to me. And then after seeing this for a whole year, people bring in Facebook with some policy decisions or political outcomes, or it's an amazing way of combining data sets. So we also try to look for what are the data sets that we could combine, and then we can start asking important questions that we could not ask before. And this geographic information is just one type, but it could have been something else. And, but it was just like, oh, now we see all this data is becoming free, and all the computer vision models are now also advanced so much. So there's this opportunity to do this kind of research. But I think it was more like a random stumbling upon kind of, yeah, to be frank.
Mark Harnett has a question. You have to unmute.
Sorry, I was in my moment. Very interesting talk. Well, I'm part of Kudan, but also I'm professor in Cologne, which I see is not very far from where from the Max Planck, right?
Yes, Bochum.
Yeah, Bochum. I didn't know this city, but I see that it's very close to Cologne. Well, basically, I love these kind of new data sets of them. I was looking some months ago to do something with the satellites, but actually I didn't figure it out how to get the data. But I think it's like Max was saying, it opens really a new avenue. Well, I didn't present myself. I'm professor in KHM, is Academy of Media Arts Cologne. I'm the professor of spaces as processes, means actually makes a lot of sense. I do a lot of things, but my seminars normally are about installations that work with the spaces, with processes. The last seminar is about AI. This year is about AI and robotics. But this kind of perspective of how to see the spaces different also will make a lot of sense, like through satellites and so on. And I was like artist in resident in the Max Planck Berlin in the IAT Rawat group. Just like last year, well, this year in the beginning, in the human and machines group. I'm still visiting researcher in the IAT group. Means I don't know. Maybe I would love to visit one day. I'm in Cologne normally. Every second week.
Wonderful. Yeah, wonderful. Yes, Bochum
I can send you an email. I really would love to come and meet what these researchers, what you are doing in there with this kind of data. And I mean, I'm more interested also in kind of which perspective could be creative to do this using this data. I mean, I think that there is a lot of potential for doing things with this creatively.
Yes, thank you. Please, that would be wonderful. You're my neighbor.
Maybe we should do it a little systematically. So we have sort of like 45 minutes, and you covered a lot of breadth.
Yeah.
And if you have questions, like put your hands up. But maybe we could sort of like go in a sort of either go back or restart at the beginning in a sense. So you talk about a lot of things which sort of like are sort of very relevant in a lot of like areas that are related to cultural data analytics, but have not been put together in this way. Like nowcasting is sort of something which is clearly an application which most of cultural data analytics typically doesn't have the opportunity to do because they don't have that kind of like up-to-date data. There is something else which is, I think, a common thread, which is you have this sort of like global coverage. That's true for satellite pictures, but it's also true for your import-export data. That's also true for the sort of like information contagion with the sort of like information during the coronavirus and so on. So you clearly have a sort of like motivation to look at the same phenomenon but globally.
Yes,
right?
exactly. Yes, yes.
That's really cool.
Yes.
Can you like, how did you arrive at that motivation, and do you see there are limits? Like I think if I remember well, from people I know doing similar things, import-export data is one of the very few things which basically does exist, which is global in very granular detail, right?
Exactly. And it's very, I mean, import-export data there's a lot of information about the trends for import for the countries. So we have to go through a really, really strict NDA to make sure that we are, we also get the anonymized data set, but also it could be a very critical data that other countries could try to infer what these firms are doing. So it's a very, very sensitive data set. So we try to get the algorithm, and we give it to the World Customs Organization, and they will run the code on behalf, for example. So there are a lot of multiple steps of things that the CARE had to go through. But I'm very interested in looking at the global trends, and by doing that, can it also benefit? There's some benefit to humanity. For example, we wanted to see if we can help increase the revenue for the developing countries and the member states of the World Customs Organization, because many countries have AI programs, they use it, but then the other countries don't have AI researchers or the GPU resources. So what ended up happening was we gave the code for free, but there was no one who could adopt immediately. So our project turned into capacity building, and our researchers went to Brazil and many other countries to teach AI and to teach how to run that. So it's not just a algorithm, but it's more like, how do you continuously make people use it and get benefit from it? And then see what is the bottleneck for them to adopt, and for example, interpretability in this case, and how do officers feel about using it, and what kind of officers are more likely to use it or not. So maybe the novice officers are willing to use because there's no piled up in deep insight yet, but the experienced officers, they can get in, they are contributing in different ways. So I like to see how this gets used and it somehow benefits. So without the benefit, it's not so charming of a project to me. And
Nice.
Yeah. Yes.
This actually, I think, is sort of something which is a thread which also goes to this contagion project, right? One of the interesting things there is that one has the feeling like, if you come out of network science, you think, oh, okay, so this is SIR, like, you're susceptible, you're infected, and then you're sort of like, you're good, you're good. But in fact, there is one difference in the research of information spreading versus disease spreading. Disease spreading, you just need to meet one person with the flu. Well, you won't buy an iPhone if I tell you to buy an iPhone. But if your grandmother tomorrow says like, hey, you should get this new phone from Apple, and then like, I have nothing to do with your grandmother, you probably do it. There's like famous paper by Michael Macy. So is that something you see where you say, oh, okay, we look at a phenomenon that is like disease-like, but actually now that we look at the global scale, do we need other models?
Oh, yeah,
you still do SIR and SAS on that?
I really fall for these, complex contagion, like the Michael Macy, and I think these are really beautiful theories, and I do see they are at play. But it seems there are multiple models that are at play at the same time, because in the real world, it's just really, it's far more complex than to say this model is much better fitting than the other ones, because in one society it could, but in the other societies, yeah.
So is that platform dependent, or is it dependent on personality of the?
I feel I cannot say, but I feel like it's like really a combination of all. For example, we had a huge debate about like the whole community had a debate about should the large seed propagation work versus like the influencer. And when on Twitter, we see both happening. So for example, when the conventional ways like Oprah Winfrey joins, and then there's like huge followers, huge number of people join Twitter just because Oprah Winfrey joined. It's the influencer network, but also we see it's the peer network. It's like that's very, very important as well. So there's, you know, these competing theories. We see them both happening in life. So I think every case I think it's really interesting to say that all these theories are at play.
So this was a
Yeah.
really hot topic like 10 years ago.
Yeah, exactly.
And now people don't do so much research about what type of contagion.
Yeah.
happens. And that's not because the problem is solved,
Mhm.
or we just got tired of it, or people.
I do not know, but now there are new type of agents, new type of entities. So it used to be human network, and then it used to be human and like rudimentary bot network. And bots at some point was taking up like 40% of the Twitter. There were some reports that were saying there are more bots now than the machines than the humans. And now there are really smart agents in these networks, and their behaviors completely different. And will we be able to settle down with what kind of model that there is? Yeah.
So this actually, I think in the off chance somebody who has money for funding cultural data analytics and data science more general, I think we need to emphasize that like in the past, like the humanities tried to define terms based on what the cognitive limit of a single researcher was. The physics of complex systems, and try to produce mathematical models like the ones by Michael Macy in order to sort of like compute and calculate what can roll out. But what was severely underfunded in the last 50 years is sort of the actual observation of what's actually happening. And what you seem to do here is like you make a really, really, really strong argument, you know, to cite our friend Ginestra Bianconi, is not to shut up and calculate, but shut up and observe. Great.
Yeah. Maybe that should be my motto, daily motto. Let me just add on to the user type. I think that there's something really interesting happening these days. So how far agents can advance. So there's something called theory of mind. It's a meta understanding of, you know, what other people are thinking. So let's say there's a rumor, and then we could even say, oh, maybe Petter believes this rumor because he also believes in another rumor. So we have a meta understanding of how the other person thinks. And now language models can implement theory of mind. So language models can understand why this particular user is behaving, and it could also strategically say, if I want to impose this information, I will have to pose it in this way as opposed to the other way. So that's really scary.
But do we have enough data for that? Because I think Google recently published, you need like 4 hours interview, and then you can deconstruct the person. And also these games like Prisoner's Dilemma and stuff. But can we extract these behavior from the social media?
I would assume it will, the basic, I mean, there's always the level, like, are you 99.9% or are you like, yeah, exactly. But the surprising fact is it is now being implemented, it's implementable. The basic, the benchmarks really show that it could be implemented. It could be implementing many different strategies. So I worry about the case in the future. I have conversation with someone for multiple years only to find out that was a virtual entity. And that's, that's would obviously happen, but how do we recover from there on? What kind of therapy should we be preparing for? I mean, because I would have made my financial decisions. I would have made, I would ask for advice on where should I send my daughter to for university. And so a lot of important decisions would have been discussed together. And the feeling of loss, I cannot imagine what would it be like. So I feel like we need to be preparing for that. Now we have.
But people do delegate these sort of decisions to ChatGPT, knowing fully well that it is not a human.
Yeah, willingly, if you are willingly doing that, but if you are unwillingly doing that, I feel that could be a shock to to many people. Yes.
But the follow-up question would be then, what about the validity of social network research we're doing if the majority of the
Our agents, yeah, it's that's really interesting because we don't know, we don't have a way to verify. There are some tools like Sam Altman's the word with the scanning your eye to make sure that you are a live human being. So there are some companies that try to do like human verification, but it's really hard to know.
So there's an equivalent in human interrelations, which is who can you 100% trust, right? And not all humans can trust their parents, and most of them find out not when they're kids, but a little later. So there is probably precedent for that kind of loss where you say, oh, okay, so there is certain things which need to be reconciled.
Yes.
In a sense. Now, this is related to what at the very beginning of your talk, you actually made an argument for like this probabilistic sampling.
Yes.
So there's no such thing as ground truth in social media because you never get everything. Like even if you, if you look at Twitter, for example, nobody has the whole fire hose. They get the 10%, and then obviously you're already in that territory. So now the key question is that sort of, can this be rolled into the same problem? Like, is there something where you trust something like that agent? Is that sort of something that sort of like is designed to deceive you, or is it sort of like, the problem with LLMs right now, it's like some probabilistic average, which is sort of boring. You don't want to be that, right? So in some sense, is that something where we can think anew about like, what does it even mean to sort of like establish trust?
Yeah. Like how do you establish trust?
And in the same way as you establish scientific validity, which is also a form of trust in a sense, isn't it?
Yeah. For the UN, that collaboration, we wanted to know, refine the algorithm because it was also very costly to monitor all the users, like you said, even if we have 10% decahose, and it was still expensive. So we wanted to see, could we have monitor even smaller set of users who are more quicker or more accurate in describing, so that we so that was the idea behind, like, can we make a smaller observation and be more accurate? So there's always yes.
About I guess similar to the AI thing, I'm wondering.
Can you speak up a little so the microphone
about this AI question from before? I'm wondering, like, in the sense, I'm not sure. I'm not so up to date. Like, what technique is being implemented for theory of mind? But in general, even now, even before, when you talk to an LLM, the way you talk, your syntax, your speech pattern is part of the calculation that goes into giving you an answer, because the order of the words and the style, they all match the sort of perceived response pattern that should be, right? In the end, it's just it is a one-to-one correspondence. There's no randomness in that process. And so in that sense, the theory of mind seems to almost be encoded into our speech pattern. Or at least like a simulation of it. Not even really a simulation of it, but like something that can give you a sense of what we derive theory of mind from. And I'm thinking how, because I like your sort of approach in general as you combine it, observe being the operative word. How do you feel about my sense is that there is growing space of operationalizing a lot of concepts from the social sciences and borderline philosophy on exactly theory of mind, on what how do we build these umwelts, these inner worlds? How do we establish what even trust is, right? Because the more it seems we are dealing with literally creating, a simulacra of potentially another one, we have to start actually defining mathematically these things. And I've found specifically this idea that the way LLMs operate and people talk to them, it's almost, in effect, they seem to not really care that it's not human because they ascribe the features to them, but where are the limits?
Yeah.
I'm getting off track here, but however you synthesize that question's meaning.
Your feedback sparked a few thoughts for me, and maybe just pointing out like two items is that one of the study that I skipped was looking at people's baseline sentiments before COVID. If someone's on average positive, and then someone's on average negative on Twitter, and then COVID happens, everyone becomes scared negative for the first 1 year, but after 2 years, 3 years, do they a little bit shift negative, or do they come back? So that was the study that examining people's baseline mood. What we find out was people who are generally positive before the pandemic, during the pandemic, they continue to say, oh, we thank the medical staffs for all the help, and they find ways to be thankful, grateful, positive, and they are mostly in the positive zone after the like 2 years time. People who are negative find ways to say something negative about COVID. And then they also mostly remain in the negative zone after 1 or 2 years. So to me, it seems like there's the filter bubble of how we see the world. So it's not, obviously, something strong will shape us, but we all seem to have our own filter. And then we look at the word based on this filter, and it seems like building this filter is so important. So before, maybe we use, I don't know, internet or social media, maybe we do 5-minute meditation, and then, yeah.
I'm wondering about what might be unleashed if this research is continued, but it's going to happen anyway. But yeah, I was thinking specifically because, at least I think that a proxy of this theory of mind is probably embedded in LLMs because of the way it's been trained on different speeds.
Exactly.
The same thing might be able to be done then for sentiment analysis, not looking at the frequencies of certain positive, negative words, but constructing more of a construct that represents an inner vocabulary.
Inner vocabulary, yeah.
Then you could potentially categorize people based on this internal verbal categories, and that might be a key to other predictions. And by what you describe, it seems like that filter, this other construct, might be relatively consistent once it's formed, which would align with how people seem to be.
Yeah, I just want to comment a little bit on that. So I'll ask you about the role of AI in science. So many of my kind of social and behavioral science colleagues, for them, like generative AI, that's really a watershed. So before generative AI, in this kind of era of big data, then AI was this superhuman predictor. And in a way, I think that's what you represent to me a little bit. But now, with generative AI, to them, AI became much more recognizable. It's just like a person, and you can just replace people by AI, and things get much easier. So I'm curious, how do you see, like, because when I hear you talking, there is no such kind of watershed like before and after ChatGPT.
Yeah.
So what do you think about AI?
Yeah. So So I think I really could see like it's kind of reflecting how we voice to the AI, then its reply would really reflect that. But also, if you would use it for maybe temporarily, that is true. But if you use AI for, let's say, 5 years, 10 years, and then I think there will be some trickling effect that it would also impact the way that we behave. And so I worry about this little bit of moving, the norms, maybe 0.1% of norms.
Okay, so this is
Yeah.
like the impact of AI.
To the humans, yeah, over the long sustained relationship or over a long time, yeah.
What about like AI as a tool for you as a researcher?
Yeah, it's a tool for me. I use it. I am using it for so many things. So I use it, just beyond like asking for a summary a lot of the times, and then also I try to ask for, because I don't know as much literature, I ask for give me different views, or that's a frequent use that I have. And it's really helpful because if I would do Google search, it wouldn't give me different views, but it would, lay out the space. But I cannot say how representative that is, but it's like today, I feel like I am the shut up and analyze that mode. But I always, because I am more of a practitioner researcher, I always long for what are the theories that are central, and I find beauty in that. So I really admire the part, and I feel I am more like a data scientist. And so I always look for ways to learn about what are the existing theories, like, what Michael Macy or Duncan Watts or other people are doing. And to me, it's an easy way to, AI as a tool, it's an easy way for me to quickly learn about, yeah.
I mean, like how data science can contribute to theory, that's another question I wanted to ask about. But there are other hands on the hand.
Basically, I wanted to continue this thing. Well, there was this moment with your customs officer network, and there was you said that if it is interpretable, it is better for them, and they better take up. Number one, I wanted to ask how you achieve interpretability, how exactly it's done, and number two, whether it is possible to use at current level, at current stage, to use LLMs to sort of on top of existing AI programs to add interpretability in a way that people can understand.
Yes, so there is a really interesting thing about what humans perceive as interpretable. So there's explainable algorithms, which is more like post hoc explainable. Like we say, oh, these were the features, like in the decision tree, it was somehow stood out. But then the features are usually not, humans cannot really understand. Oh, there was this feature, it usually measures this, and this was above 0.5. So it actually doesn't mean much, but still officers were feeling, okay, although this feature doesn't mean, much to the human sense.
Feature is like there is sort of spot on the left angle or whatever. What sort of object can be a feature?
So a feature could be, the average price of the unit per price was above something. So there could be any feature, but just the fact that the algorithm gave something, that was more important than understanding this feature itself. So and then I also asked about so this is more of a legal domain, because when you delay some import and other things, it could be the product could go bad, and there's a timely delay, and then officers may have to explain to the importer why they have to open it and maybe ruin the package, and it's a costly thing. So maybe there's a responsibility that comes into play. But what if this was a medical diagnosis? It's like, do you have cancer or not? Do you really want to know the explanation? But at the cost of no explanation, you want to have higher performance. So it seems like it really depends on the field. Some fields, because the officers sometimes have to explain, like the tax officers come for auditing and they would ask, why are you coming to us? You know, they should be able to explain something.
Yeah, but even in medical data, some sort of interpretability is good to, for example, to avoid overfitting.
Yeah.
To make sure that,
Yes.
that it is not identifying, I don't know, photos by some bizarre,
By the ruler.
by the shape of the ruler, you see.
Yeah, yeah.
Just one more thing I wanted to add, maybe if it's of interest to you, because when you mentioned that it's like you talked about this research and that it seems like you mentioned the word filters. Like people seem to have like these filters that are relatively persistent. It just reminded me of something I looked it up quickly as deterministic screens might be a
Deterministic screen.
of interest to you. It's by Kenneth Burke, linguistic essayist and philosopher. And so deterministic screens, they essentially kind of encapsulates what you're talking about very closely. Of course, it continues on in general in critical theory and in a lot of philosophy, but that seems to be like probably a really operationalizable term.
Yeah, thank you.
If another thing is then Sapir-Whorf hypothesis about linguistic relativity. I think these two go together well. I have a whole notebook of these concepts specifically for this type of interest. So these, I think, connect maybe of interest to you. That's it.
Thank you so much. Yes.
I think this is sort of like a really cool. So there's linguistics.
Yeah.
Like Sapir-Whorf is really basic linguistics, which is great to hear out of a cognitive scientist. It's great. One of the interesting things here is that we're sort of like circulating around an issue which was an issue in machine learning and in artificial intelligence, what was previously called that, which was all about reasoning and causality and trust layers and stuff like that. And one of the interesting things is that this, if we say, okay, yeah, let's shut up and observe, there is a lot of other things that come for free with observation, which remind me all the time of like music, like for example, if jazz musicians are on a stage, or also something which if you're in a high density but tense situation, like you're skiing a forest and stuff like that, where you don't have time to think about, yes, you trust your vision, but you don't think about causality. You know exactly what you're doing and you don't have time to compute, basically. Yes. So that is sort of something which my question here would be like, if you then observe these kind of things where you say, oh, okay, I do not know if it's Michael Macy's model or is it regular SIR, irregular SIS, or whatever sort of some other people come up with. I assume, and I think this is a really amazing assumption because I have that also in many areas. I think we actually should not say, oh, is Laszlo Barabasi right about the emergence of scale-freeness or Aaron Closet? It's probably a mixture of both, plus some other mechanisms which we don't know. Yes. And of course, that can be just as wrong because it could be just Laszlo or just Aaron.
Yeah.
Right? But I don't want to make the decision. I want to live in a world where I sort of like let that open. But there is one thing I can walk out the door with, which is my observation. I can test my observation and retest it because I have multiple filters. And that is one of the core assets that our brain and these machine learning things have in common, which is, there is plenty of neurons that are all like filters in these neural networks. And down the road from you in this other Max Planck Institute for Brain Science, Wolf Singer, since 30, 40 years, says, oh yeah, whatever we perceive is mixed up in the brain anyway. The problem is the brain scientists are bifurcated into different specialities. Yeah. And so the question is, can we disambiguate that signal in some sense? So what is it what we learn when we don't try to tie down to a model? But do you think there is something in these satellite pictures, for example, which is more general than
Yeah.
these models.
Yeah. I wish I could say that, oh, they all have this unifying theory across the data that I see, and here is my grand theory of X. But I think it's so. I think that the theoretical works are beautiful.
Mhm.
They're beautiful. I really admire that. But then I see the collaboration that I do in practice with NGOs. I see the immediate benefits, which is also really, really helpful. And it's much needed now because there are less funding for NGOs. And so I don't think I have this whole connecting theory across all of that. But if I see maybe some of these observations may no longer work in the future when we have completely different, maybe the social mechanism changes, maybe the platform changes, maybe there are more AI in the system and so on, but that is fine. So for now, if I see there's the strong benefit and there's no one else looking at this, I am happy to work on it. So it's more like, that's the passion for the data science for humanity, whatever that means, is something that drives me. But this is, I have to be frank that my earlier research years have been more computational oriented. So we publish more like detection algorithms, how to do this methodologically. And all of this started happening post tenure. So post tenure, you're free. You leave only one time. So do whatever you like. And and along the way, we don't start with the grand theory and say, okay, my lab only works on this particular problem. But once we start working with one NGO, and then we hear about the problem, and then there are so many technical challenges that we have to go through, and that becomes a very technical paper, and some of that becomes a very applied paper. So there's the real world challenges are really fun and difficult.
Yes.
And then while we do that, we try to bring in like amazing people so that in the field, so we always work with, for example, economists and sociology faculty, because they can help us interpret what is happening, and they can bring the theory together. So I try to borrow this theoretical knowledge from collaborators. Yeah. But I'm more excited about, is it actually used?
That brings me to another thing, like borrow it from collaborators. You obviously have a good hand in doing so, but then also means you need to find these collaborators. So how do you have a strategy of sort of like aggregating teams that work on a problem?
Now I have a super diverse team. I have one postdoc who used to work with mice, neuroscience postdoc and I have a geographer postdoc who used to live in slum and interview people. And now he's in my lab working with AI researchers. And I have someone from electronical engineering, communications researchers. So we have really, really diverse team. And we cannot orchestrate well, but as you know, when there's a really diverse set of people and you give them, you empower them and you let them, less hierarchy for sure, and then just let the conversation happen, and then there's something amazing happening.
Yeah.
So it's the.
So you mean it's more moderation and less conducting in a sense?
Yes, I conduct less. I cheer up. I'm the cheerleader more than I'm not like the big shot who says you have to do this and this and this. But it's more like,
I love it.
yes.
Basically, speaking of the geographical part and all these models to recognize something from satellite images. I understand that now, well, just wanted to invite you to comment on the possible connection. I understand that there is a lot of people who do sort of similar stuff, monitoring what's going on in the war zones.
Yes.
For example, there is, I think, this some sort of AI model in which The Economist uses to monitor fires along the Ukrainian-Russian front, and there are these guys who did the monitoring of destruction in Gaza.
Forensic architecture.
Forensic architecture, and that's one thing. Sort of, it is interesting that probably there must be similarities. And one thing I thought about: is it possible to do something along the same lines to monitor sort of, for example, repression or some sort of human rights abuses inside sort of a closed country, like for example, North Korea is obviously a true example. Also, we know that there was when there was this discussion of the Uyghur question in China, there was lots of people who looked carefully at satellite images, trying to understand where are the detention centers. Is it possible to somehow automate this?
There are studies that try to look for detect like factories related to child labor, and also on satellite image space. Not everything is true. Some places there's like fake buildings, and they even put the light up, and these things happen. And we obviously don't know what happens inside these buildings or underground. So, and there are many studies that look for illegal dumping of trash, and I think these are there are studies that focus on these themes. I try to avoid the themes because it's really hard to we have an observation, but then we also want to somehow have a ground truth to that, and that's the challenging.
Should be evidence from the ground.
Exactly. So instead, we try to look for problems that NGOs already have. There are so many problems they have. So, and then we talk with them, and we try to see which are the most important problems that would help this problem, and do we have the technology to do that? Does it align with what the capacity of my team can do? So I think that comes into play, but often we have to exclude politically oriented, all these open-ended questions. Not because they are not less important, but because it's hard to validate, and at the end we need to. Yes.
I think this is sort of like an interesting point that we should make, that the satellite images, they are used for a lot of things, as you point out, and they also have, basically they're like space telescopes that point down, right? And that means they have all the same sort of like complexity. So you get all these multispectral bandwidths and stuff like that, which have been used for a very long time to, spot radioactivity, submarines, and like all this like fancy stuff, because they were actually for that kind of purpose. And I do think, despite that we don't want to repeat what other people are doing, it is nevertheless interesting to sort of like have a sort of emancipated relationship to that instrument, and say, hey, okay, what are these other bands? What can they do for us? Can we learn something about that even over time and stuff like that? And that is unfortunately not something we learn, right? Like we are, as a player for cultural data analytics, where linguistics is hopefully overexpressed, human behavior sociology is hopefully overexpressed, and then actually in the visual, we also, even though it may be a marginal thing relative to language and sociology, there is still a problem, which is sort of like we have this, that visual is underexpressed relative to text, but it's overexpressed relative to all the other modes of how you can perceive, including the visual, which is not within the bandwidth of the human eye, right?
Exactly, yeah.
So that is sort of something where I would be interested to sort of like hear your take of like, do you see certain areas which like culturally have not been harnessed, basically?
No, I mean, even just within satellite data, there's something called the SAR images.
Yeah.
And SAR images can see through clouds, and which is amazing, but it's another level. It's not as simple as RGB because you have to compute, and so I think adding new data set there's a big jump. You have to invest maybe a year to get to know this, and you have to train the researchers. But there are really, really interesting data sets. Like I want to also use. There was the slide with all the list of the data set, like the animal migration and other things. I would hopefully want to use all of that, and maybe something in the future, like the neural signals. So when we receive information, there's something that makes us like happy or sad or satisfied or in a way. And that would be a good clue for why you fall for certain information and why not.
Yeah.
So I feel the human sensory data would be something that I would love to connect in the future. Yeah.
We have to wrap it up. We spent 2 hours in the discussion. Thank you very much. We will meet next week with, 2 weeks, right?
In 2 weeks.
In 2 weeks, because there's fall break here at the university. So in 2 weeks, Melvin Wevers from the University of Amsterdam, and he will speak about the architecture of information, particularly in the realm of politics. Thank you very much. See you in 2 weeks.
Thank you.